Hello everyone! Welcome to ICP DAS's webinar. This is Alla from the International Sales and Marketing Department. We're grateful to have you all participating in our webinar today. The Smart Factory plays a critical role in driving innovation, improving efficiency, and staying competitive in today's fast-paced industrial world. In today's webinar, we will show you how ICP DAS's Smart Factory solutions are accelerating the path to IoT in various industrial sectors. In today's webinar, we will first explore the features of smart factories, followed by 4 case studies, showcasing how ICP DAS assists its customers in adopting smart factory technologies. Let's begin by exploring the features of smart factories. The future of smart factories is marked by the continued advancement of technology and data-driven automation, which will lead to increasingly connected and intelligent manufacturing ecosystems. The key features of smart factories are Industrial Internet of Things, IIoT, is the heart of the smart factory, which refers to a network of connected devices, sensors, and machines that collect and exchange data. IoT devices and sensors play a central role in enabling real-time monitoring, control, and optimization of manufacturing process. They provide valuable insights into machine performance, energy consumption, and production quality. Advanced data collection and analysis drives informed decision-making. By analyzing large data sets, it identifies patterns, trends, and opportunities. This not only enhances operational efficiency, but also offers valuable insights for strategic planning and product development. Robotic automation. Advanced robots can perform complex and repetitive tasks with high precision and speed. From manufacturing to logistics, robots are changing the way processes are managed, freeing up workers to perform more important and creative tasks. Human-machine collaboration. While automation will continue to play an important role, the focus will also be on human-machine collaboration, with workers using advanced technologies to expand their capabilities, improve safety, and perform more complex tasks. Supply chain integration. Smart factories will be seamlessly integrated into wider supply chain networks, enabling real-time transparency, collaboration, and flexibility across the value chain. This integration will enable customized manufacturing process that can quickly respond to changes in demand, supply, and market conditions. Green manufacturing. There will be an increasing emphasis on sustainability and environmental responsibility. Smart factories will use renewable energy, optimize resource use, and minimize waste generation. These include initiatives such as energy-efficient operations, closed-loop manufacturing, and environmentally friendly product design. ICP DAS offers a vast selection of products tailored to address a wide variety of industrial challenges. This extensive product line serves as a robust foundation for transforming traditional manufacturing setups into sophisticated smart factories. The range encompasses sensors, I/O modules, communication devices, edge controllers, software tools, and much more. These solutions enable clients to streamline production process, improve operational efficiency, and embrace Industry 4.0 concepts, paving the way for seamless shift to modern, connected manufacturing. In this part, I will present 4 case studies showcasing smart factory solutions offered by ICP DAS. Let's begin by exploring the first case study, stack-light monitoring for streamlined CNC machines. The client in this case study is a manufacturer and distributor specializing in production of aluminum alloy products. Previously, manual inspections of CNC production lines caused increased risk of errors. Manually recorded data lead to inaccuracies, hampering data reliability and decision-making. Limited automation. Lack of real-time monitoring delayed the identification of problems, which directly impact production efficiency. Reduced machine energy efficiency. Inefficient machine energy usage resulted in a higher operating cost, increased carbon dioxide emissions, and negative environmental impacts. The customer adopted ICP DAS's TSL series stack-light monitoring modules to enable real-time monitoring of their CNC machines. Now data is collected and transmitted to MDC series data concentrators via Modbus RTU and then sent to the control center through Modbus TCP, simplifying centralized machine performance management and increasing machine availability. By leveraging precise control and management provided by ICP DAS's modules, factories can achieve digital transformation while meeting carbon reduction targets and embracing ESG principles. The customer used the TSL PA4R1 series stack-light monitoring modules and the MDC 714 series Modbus data concentrator to monitor the real-time status of their CNC machines, providing unified machine performance management and increasing machine availability. ICP DAS's stack-light monitoring modules provide customizable color signals and detection of the flashing status. Clients can set the meaning of different color signals like operating, idle, processing, and error. These signals are combined to form a status value that is directly read by the modules. This eliminates the need for individual interpretation of each light signal. Besides, modules can detect flashing status, ensuring continuous monitoring of machine condition. Report the historical data of the light status in time slots. This function allowing users to know the amount of time a machine spends running, troubleshooting, and processing. Integration with MES and ERP systems provide additional functions, such as calculating equipment availability and analyzing the causes of downtime and standby conditions. Low network load. Stack-light monitoring modules support both Modbus and MQTT protocols. Unlike before, when pooling was needed, these modules now instantly transmit light status changes to the control center, reducing network load. Both stack-light monitoring modules and MDC series Modbus data concentrators featured a built-in web server for easy installation and configuration. Users can access and customize settings through a web browser on their smartphone or computer without requiring additional software or programming skills. Its integrated microcontroller MCU helps reduce the workload of the central controller, allowing it to operate more efficiently and focus on other critical processes, leading to better overall system performance. The image demonstrates how stack-light monitoring modules report the light status in specific time slots. The modules can detect whether each color segment of the stack light is off, on, or flashing. In addition to monitoring individual segments, they can also define and combine status of multiple color segments, with the ability to track and report the duration of each status. Integrating the TSL PA4R1 module intro system allows easy stocklight status monitoring on CNC machines through SCADA software, leading to improved machine utilization and throughput. ICP DAS's MDC series Modbus data concentrators also provide CSV file setting configuration and easy equipment management, allowing users to edit settings in spreadsheet programs or simple text files. By importing these files, users can update Modbus RTU comments for multiple slave devices at the same time. Comments can be added for ease of reading, and files can be password protected for security purposes. Data pool for up to 9,600 data registers per data type and up to 250 Modbus commands. Support for up to 8 Modbus TCP connections at the same time. It also enhances the system's scalability, allowing it to accommodate future growth and additional components without sacrificing performance. The diagram illustrates how the MDC 714 consolidates registers to streamline communication. Also, files can be exported, imported, or quickly duplicating multiple MDC 714 units. In the provided solution, ICP DAS's TSL series stocklight monitoring modules work with the MDC 714 Modbus data concentrator for fast transfer of production line data to the control center. Anomalies trigger immediate alerts, allowing for rapid troubleshooting and reduced equipment downtime. Each of CNC machine has the TSL PA4R1 module for stocklight monitoring, sending data to the MDC 714 via Modbus RTU, which then forwards it to the control center. ICP DAS offers two series of stocklight modules, the 4-channel TSL Tiny series and the 6-channel SL Wireless series. Both can minimize human labor and machine idle time. In case of using a wireless module from the SL series, there is no need to install a Modbus data concentrator. Customers can simply use a Wi-Fi access point, as illustrated in the diagram. ICP DAS's stocklight monitoring solution solves production process pain points by implementing TSL series modules and MDC 714 Modbus data concentrator. The solution automates data collection from CNC machines. This eliminates manual data recording, significantly reducing the risk of human error and ensuring accurate and reliable production data. The integration of TSL PA4R1 modules with CNC machines enable real-time monitoring of stocklight status. This automation streamlines the data collection process and provides instant alerts for any anomalies, minimizing the need for manual intervention and increasing overall automation in the manufacturing process. The implementation of TSL PA4R1 modules and the MDC 714 data concentrator improves machine energy efficiency. Energy-efficient machines not only help in reducing carbon emissions, but also contribute to a smaller environmental footprint, supporting sustainability goals and regulatory requirements. The next case study will focus on wireless overhead crane control for safety in hazardous industries. Customer in this case study manufactures monorail-type overhead cranes specifically designed for bicycle painting lines. These cranes are utilized for suspending bicycle frames during the painting process. to minimize the health risk associated with the formation of heavy metals from abrasive and debris generated by sandblasting, as well as to simplify communication with the crane without the need for physical lines, the customer was looking for a wireless method to remotely control the crane. Previously, the customer used Zigbee wireless equipment. However, they faced communication delays and interruptions in the launch of overhead cranes, which resulted in inaccuracies in crane positioning. This was due to the interference between Zigbee modules and crane motors, both operating on the 2.4 GHz frequency. The customer utilized ICP DAS's M7000 series I/O modules and RFU series wireless modems to establish radio frequency communication between overhead cranes and ground-level PLCs. This setup enabled the cost-effective implementation of a remote control system for overhead cranes and ensured a safe working environment in bicycle painting production lines. In this case, the customer used the M7055 NPNG series I/O module and the RFU 433 series wireless modems to establish communication between overhead cranes and ground-level PLCs, enabling the control of overhead cranes. ICP DAS's remote I/O modules support diverse communication protocols and I/O signals, including analog and digital signals such as current, voltage, strain, and temperature, to feature the dual watchdog function for system safety during abnormal situations, and include isolation and overvoltage protection. The M7055 NPNG module controls up to 8 devices on overhead cranes with a 700 mA load capacity per channel and customizable safety functions. The RFU 433 wireless modem solves wiring issues in harsh industrial environments, reducing labor and material costs while making troubleshooting easier. It operates on the interference-free 433 MHz ISM frequency band, offering cost-effectiveness, low power consumption, long transmission range, and easy setup with knob and DIP switch controls for simplified maintenance and replacement. The structure of this solution can be divided into two parts: the overhead crane's upper side and the ground side. The PLC on the ground side transmits control signal to the RFU 433 wireless modem through RS485 Modbus RTU protocol, utilizing the 433 MHz wireless frequency band of the ISM band. The signal is transmitted to another RFU 433 wireless modem on the overhead crane. Subsequently, the signal is transmitted to the M7055 NPNG module to control the operation of overhead cranes. ICP DAS's wireless monitoring solution solves production process pain points by enabling remote control of overhead cranes in bicycle painting production lines. Now operators can manage crane operations from a safe distance, reducing the risk of accidents and potential health hazards associated with manual crane control. By implementing the M7000 series I/O modules and RFU series wireless modems, the setup process for establishing communication between overhead cranes and ground-level PLC is significantly streamlined. This eliminates the need for complex wiring and reduces setup time, allowing for quicker deployment and operational efficiency. By facilitating seamless communication between ground-level PLCs and overhead cranes, utilizing radio frequency technology, control signals are transmitted wirelessly, enabling swift and efficient crane operations without the limitations of traditional wired systems. Next case study will focus on machine data visualization for enhanced monitoring of India's largest aluminum wheel plant. The customer in this case study is India's largest machine tool manufacturer, specializing in customizing production lines and offering intelligent solutions to the world's leading manufacturers of aluminum wheels for passenger cars, commercial, and special vehicles. The client approached ICP DAS to address several production challenges, including complicated factory layout. The factory consists of 5 production lines, each equipped with 5 pieces of machinery, including 3 laces, 1 robotic arm, and 1 conveyor belt, totaling 25 machines that require concurrent monitoring. Limited availability of information. Due to the limited size of the HMI screen, real-time access to critical data, such as production capacity and equipment failure status, has become difficult for management personnel. Sophisticated production control. To optimize production line control, the customer was looking for a new solution that focused on enlarging the display to improve visibility of machine conditions, enabling real-time monitoring and achieving production optimization goals. ICP DAS's iCAN 116S series industrial LED display and the GW7663 series Profinet to Modbus TCP gateway module enable reading and display of machine status from the PLC. This allows management personnel and equipment engineers to instantly access real-time production capacity information, reducing workforce expenses and improving production line management efficiency. Users can prioritize emergency messages on ICP DAS's iCAN series LED displays, ensuring prompt response to critical situations on the production line. The iCAN series display efficiently communicates on-site equipment malfunctions by displaying errors or emergencies. It also pinpoints the location of the emergency using arrows and offers direct connection capabilities to PLC, eliminating the need for the intermediary PC. The iCAN series display supports options for different text colors to indicate urgency levels, enhancing message readability. Messages can be easily edited or inserted using standard web browsers on computers or even smartphones, offering unlimited options for message customization without the need for special equipment or location restrictions. The iCAN series display also features multi-language support and built-in Modbus TCP RTU protocols. The images show how the iCAN series displays provide instant, enhanced access to critical production information. They help operators quickly respond to any problems, increasing the overall safety and efficiency of the production process. Watchdog timer function of the GW7663 gateway module allows users to set communication timeouts between the iCAN series display and PLC, enabling automatic detection of communication failures and display of preset warning messages, facilitating quick problem resolution and improving production efficiency. With this module, data exchange between controllers and the iCAN series display via Modbus TCP can occur at bus cycle rates of up to 1 millisecond, providing real-time data updates for timely decision-making. The GW7663 aids continuous integration of devices using the Profinet protocols with Modbus TCP, enabling efficient communication and data exchange between industrial devices for broad IoT integration. ICP DAS's GW7663 gateway module enables a Profinet PLC to access data from Modbus TCP devices, such as the ICANN 116S series industrial display, providing instant machine status feedback. With one module and display per production line, the setup ensures complete monitoring across all 5 lines. Acting as a Profinet protocol slave device, GW7663 aids direct connectivity between the PLC and Modbus TCP devices. In this setup, the data processed by the PLC for robotic arms and laces is promptly displayed on the ICANN display via GW7663 gateway. The ICANN series display offers industrial-grade anti-noise capability, reliability, and stability. It supports ASCII and Unicode characters for multi-language text display and various communication protocols like Modbus TCP, RTU, CGI, and CANopen, ensuring compatibility with diverse industrial control devices. Specifically, the ICANN 116S modules can display up to 16 English characters per line, making it compact and ideal for installation in front of each production line. This allows management personnel to quickly access important information, such as production capacity and machine status, improving production line management efficiency. ICP DAS's machine data visualization solution solves production process pain points by providing real-time monitoring of machine status across all production lines. The ICANN 116S series industrial display, coupled with the GW7663 Profinet to Modbus TCP gateway module, offers instant access to production capacity information, regardless of the factory's layout complexity. By enabling direct connectivity between the Profinet PLC and Modbus TCP devices through the GW7663 gateway module, data processed by the PLC for robotic arms and laces is promptly displayed on the ICANN 116S series display. This ensures that critical machine status feedback is easily accessible to management personnel and equipment engineers, enhancing overall information availability. By providing a user-friendly interface for monitoring and managing machine operations, the ICANN series display offers compatibility with various communication protocols, allowing seamless integration with industrial control devices. Additionally, its compact design and multi-language text display capability make it well-suited for installation in front of each production line, facilitating efficient production management and control. Next case study will focus on precise temperature tracking in industrial ovens for optimized productivity and quality. In certain industrial processes, particularly those involving hot air ovens, lighting equipment is utilized to generate heat. This is especially useful in industries where maintaining a consistent temperature is critical, like in the manufacturing of panel products and other electronic components. Here is a more detailed explanation of how lighting equipment, like light tubes, contributes to heat generation in these ovens. Light tubes as heat sources. In industrial hot air ovens, light tubes are used to produce heat. These tubes generate heat by converting electrical energy into light and subsequently into heat energy. The heat generated is used to maintain the oven's internal temperature. Temperature regulation. By adjusting the intensity of the light, the heat output can be controlled, allowing for precise temperature regulation within the oven. This control is essential for maintaining consistent processing conditions, especially when manufacturing products that require specific temperature ranges. Daily protocol for control. To ensure precise control of light tubes in industrial ovens, systems often use the Digital Addressable Lighting Interface, DALI protocol. This protocol allows for fine-tuned control of each light tube, adjusting the output as needed to maintain stable temperatures. Monitoring and automation. The use of smart technologies, such as gateways, enables seamless communication between the DALI controlled light tubes and other systems. Such setup allows for real-time monitoring and automation, ensuring that the light tubes are generating the right amount of heat and providing alerts if temperatures deviate from set parameters. The customer in this case study is a manufacturer of specialized equipment that produces industrial ovens using advanced light and heat technology. Their equipment serves various industries such as PCB manufacturing, flat panel displays, touch panels, semiconductors, electronic assembly, printing, coating, and shoe manufacturing. The customer approached ICP DAS to address several production challenges, including UV glue aging issues. UV glue used in high-temperature environments experience yellowing, leading to reduced light transmittance, affecting product performance. Increasing manufacturing requirements. The demand for electronic products such as smartphones, tablets, LCD TVs, notebooks, iPads, and OLEDs has grown significantly. This variety of touch panel products has made the manufacturing process more complex. Oven temperature instability. The complexity of the manufacturing process, especially across a variety of panel products, has made maintaining stable oven temperatures critical to achieving high standards of productivity and quality. Since the industrial hot air ovens in this case rely on hundreds of internal lights to generate heat, to ensure these lights produce heat consistently and remain stable and reliable during the process, the customer opted for DALI lighting control module to manage them. The DALI control module effectively linked the customer's heating system with DALI temperature controllers, ensuring energy efficiency and stability in their industrial ovens. Moreover, this integration has contributed to greater production flexibility, allowing the production process to meet diverse requirements for mobile phones, tablets, large-size panels, automotive panels, and more. With ICP DAS's temperature monitoring solution, the client received the following benefits: stable protocol conversion. The DGW521 reliably converts Modbus RTU DCON to DALI protocols, ensuring uninterrupted communication between different systems. Improved energy efficiency. By connecting to the customer's heating system and DALI temperature controllers, the DGW521 enhances energy efficiency in industrial ovens, contributing to cost savings and sustainability. Enhanced production flexibility. The integration of the DGW521 allows the panel temperature process to meet a variety of production requirements. Real-time power adjustment. With its real-time and precise power adjustment function, the DGW521 assists in optimizing power consumption, leading to potential energy savings of at least 47%. Stability in operation. The DGW521 serves as a stable communication tool between PLC and light tubes during the production process, ensuring reliable and continuous operation. Supports control of multiple lighting devices. In this setup, the industrial hot air ovens PLC only supports the Modbus RTU protocol, making it incompatible with the DALI protocol. The DGW521 DALI gateway from ICP DAS offers a practical solution by bridging the communication gap between the PLC and the DALI lighting control module. This configuration allows the customer to manage oven temperatures by controlling the lighting devices that generate heat, providing greater control over the process and ensuring high product quality. ICP DAS's temperature tracking solution solves production process pain points by providing stable communication between heating systems and DALI temperature controllers, and maintaining precise control over oven temperatures. It reduces yellowing and loss of light transmission associated with UV glue aging in high-temperature environments. With the integration of the DGW521 communication gateway, the manufacturing process becomes more adaptable and efficient. It allows seamless communication between different systems, enabling manufacturers to handle the complexity of producing a variety of panel products. The DGW521 gateway also helps stabilize oven temperatures, addressing the critical need for consistency in the manufacturing process. By ensuring that temperatures remain stable across various panel products, it contributes to maintaining high standards of productivity and quality, ultimately enhancing overall manufacturing process. In conclusion, ICP DAS's solutions provide comprehensive support for smart factory initiatives, enabling manufacturers to leverage the benefits of IoT, data collection and analytics, robotics, human-machine collaboration, supply chain integration, and green manufacturing practices to increase competitiveness in today's rapidly evolving industrial landscape. Through initiative technologies, ICP DAS addresses critical pain points in production process. By providing seamless communication, real-time monitoring, and remote control capabilities, ICP DAS empowers manufacturers to optimize efficiency, reduce downtime, and enhance overall productivity. Moreover, with a commitment to green manufacturing and sustainability, ICP DAS's solutions contribute to a more environmentally friendly and resource-efficient production environment. As smart factories continue to develop, ICP DAS remains at the forefront of innovation, delivering comprehensive solutions that meet the diverse needs of modern manufacturing. Thank you for joining our webinar today. Please remember to scan the QR code and fill out the questionnaire. Once you've completed, we will send you this presentation. So now we're moving on the QA session. And if you have any questions, please don't hesitate to leave them in the chat window.